The William W. Hay Railroad Seminar Series is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, we thank the USDOT for their ongoing support. It's greatly appreciated by those of us here on campus as well as those participating via the internet. Canadian railroads have been closely linked to U.S. railroads effectively since the beginning of the dawn of North American railroading. However, some differences have developed in the two nations' approaches to operating rules and traffic control systems. Our presentation today will introduce the primary methods used and the rules framework that's been developed to provide a unified structure for all railroads operating in Canada, unlike the U.S. Our speaker, Sean Robitaille, is a transportation engineer for Canadian National's Network Operations Group based in Edmonton, Alberta. Sean is a civil engineer and graduated with a bachelor's degree in applied science from the University of Waterloo in their engineering program in 1996. He began his railroad career while still in university, working for CN in their co-op work experience program. Since graduation, Sean has been employed at CN in a broad array of disciplines, including track and roadway engineering, safety and risk management, signal systems design engineering, network capacity planning and service design, motive power planning, and transportation engineering. Sean also worked for 2 years in the consulting industry, where he led a feasibility study for a new heavy-haul mining railroad and associated requirements for traffic haulage from mine to port on an existing rail line. His current responsibilities at CN include train and motive power performance, train marshalling design, derailment analysis, and new operations analysis. Sean is also chairman of the AREMA Committee 16, which is the Committee on Economics of Railway Engineering and Operations. Please join me in welcoming our speaker today, Sean Robitaille.
Hey, thank you very much, everyone. Great to be here. I've been here a couple of times before and been to a couple of seminars in the past, so it's an honor to be asked to come and provide this presentation today and see everyone that's out here today. It's great. It's a great outlet to have discussion and get people engaged. My presentation today is Canadian Rail Traffic Control Fundamentals. And let's turn that on there. This is something that's kind of been close to just about everything I've worked on in my railroading career. But, just about everything has been centered around how we move trains down the track in one way or another. Presentation overview today, what I'm going to go over. Go over the basic framework of our control systems, which is basically the rule book that we utilize in Canada. Then we'll go through the basic formats of control that we use, which you could say uncontrolled, control without signals, being whether in yard or main line, and a little bit about the use of automatic block signals in Canada, centralized traffic control, and interlocking, and hopefully have some time for some questions afterwards. And just before I get going here, just out of curiosity, how many people in the room here have qualified in rules at some point in time? So we got 3, 4, okay. And we have 1 certified locomotive engineer in a management capacity. Okay. Yeah, basically, well, certainly from my perspective at CN, there's definitely a very strong interest in all our management staff to be engaged and get rules training. So this is kind of fundamental for all of us. In Canada, our rules are basically called the Canadian Rail Operating Rules, and they're overseen and written up and basically controlled by Transport Canada with input from the railroads and their operating practices groups. Unlike many other places in Canada, the complete Canadian Rail operating document is available on the website of the Railway Association of Canada, along with a number of other Transport Canada rules and regulations like air brake and train inspection documentation. So you can go there, you can look this up, and you can pull that down for your interest in reading as necessary. Now, this document provides the parameters by which all railways operate in Canada. This is the rule book. Now, we'll talk in a minute about some variations on that theme, but every railroad in Canada abides by this document. There's no homegrown rule books out there. Every railroad in Canada, including U.S. railroads that all own and operate track in Canada, which is limited to CSX and BNSF, are required to use this document as their form and basis of rules for operation. So in the U.S., of course, things are very different. So you might be asking, well, how on earth did we ever get to the point where we were organized enough to have a single rule book for an entire country? And that's a valid question. And a lot of it is rooted in history, because in Canada, we had a very early amalgamation into two major railroad companies and an assortment of very small associated, well, we would call them short lines today. So we had two transcontinental networks very early in the 20th century. The CP network, the Canadian Pacific, was basically complete by 1915. The CN was created from various bankrupt railroads by the government in 1924. At that stage, there were individual railway rule books, but they were all approved by government, the Government of Canada through the Board of Transport Commissioners. Until 1962, when we had our first rule book that incorporated everything for all railroad companies, and they were actually even listed on the first page behind the title page. So 1962, the Uniform Code of Operating Rules basically condensed everybody's rule book, which at that point basically all looked the same anyways, into this one document. And it has since evolved from that time, changed names in the 1990s to the Canadian Rail Operating Rules. We do, however, have the provision to do railway-specific instructions above and beyond the rule book. For example, at CN, we have our document, which is Canadian Rail Operating Rules, but it has, and that's the title page from it, but within that rule book, anything that we have added as special instruction that makes a rule even more restrictive. We can make things more restrictive. We can't make them less restrictive. But in the CN rule book anyway version, we have it in blue text to specifically highlight now where there's different areas. This company-tailored rule book also excludes rules that do not apply on certain railroads' territories. For example, in CN, we have no automatic block signal territory anymore, so we don't include that in our rule book. Yes, Dr. Barkett.
Could you go back to the previous slide for a second? And if you're going to get to this later, just hold off. But I think what you just said was that the Uniform Code of Operating Rules was adopted in 1962, largely derived from the two big transcon railroads.
Yeah.
But why? You also said something. They were essentially the same anyway. Why were they? Because the analogy in the United States would be that we don't have two different big railroads with identical rule books.
Well,
so there must have been something between 24 and 62 that led them to converge.
Yeah, for the most part, I mean, there was a lot of borrowing back and forth from the two companies, and a lot of parallel evolution, a lot of cooperation during that time frame, and it just because of basically the nature of both railroads, how they operated, the territory that they operated in, the types of traffic, the types of railroad infrastructure they were dealing with were basically identical. So there was very little difference in how either CN or CP operated over this time. Plus the fact that even back as far as 1924, the Canadian railroads had to submit their rules documents for approval by the Board of Transport Commissioners before it could be published. And in fact, if you pull up I have a couple of historical ones on file, but you'll see, just like here, on this slide here, approved and prescribed by the Board of Transport Commissioners, you'll see that wording in the older rule books that are CN only or CP only. So, yeah, back to railway-specific instructions, company-tailored rule book, and, of course, our timetable, which includes other specific instructions for operation on any particular line of track that's out there, and plus other special instructions that may apply specifically only to a certain territory. We call, in Canada, every mainline segment of track is referred to as a subdivision. And then there's also reference to yards and terminals. The timetable also clearly identifies the method of control and who oversees the application of those control rules. So this slide is just a sample subdivision page and just a portion of it from the Edson subdivision of Canadian National in Western Canada. Down the center, underneath the Edson subtitle, you'll see all the station names. Over on the left-hand side, we have the traffic control method that's used on this segment of on the subdivision. Directions to specifically identify which way is which can be very important on certain places where we're not necessarily going north by compass or east. And of course, specifically identify a number of main tracks in service between station locations, siding location and length associated with the station name. When we say siding here, these are timetable designated sidings that are used for passing and meeting of trains. And they have to be associated with a station name in order to have execute proper control. So we'll take a bit of a step back here. We'll start out here with our basic control systems for non-main track. Effectively, there is no control rule. What happens in Canada is movement is and speed is governed by Rule 105. And in this territory, trains will operate at reduced speed. They have to stop half the range of vision of equipment, or a red flag, or the end of track, obviously. Typical yard operation there, non-main track situation. There are a couple of provisions where you can designate a main track as being not under RTC control, RTC being rail traffic control, the person who oversees the operation. There's two ways of doing it. One of them is to install what we call cautionary limits, which is prescribed by Rule 94. It basically just turns the main track into a yard track. And a typical application, like I said, yards, all our spur tracks and customer sidings, ancillary tracks would all be operated under Rule 105. In Canada, we have very specific rules about how to identify what is non-main track territory. In the quickest way, besides knowing your territory, all our switch targets, when lined in the reverse position, will have a yellow target displayed. And it used to be a prescribed shape as well, but things have evolved and that's gotten a little looser over time. Here, this is a photograph on the Arnaud Railway where they use a yellow chevron there to sort of indicate you're going to the left at this particular turnout. But the yellow target is a clear indication that you're not on a main track. On CN, we have, we use what we call Subdivision Track to designate what is the through track at a particular station instead of using a yard limit or a cautionary limit application. And that will show up in the timetable as well. As I said before, rail traffic controller, who we almost always call the RTC, he or she supervises and directs all traffic, issues all authorities, pushes all the buttons, makes things happen. Our most basic method of control on a piece of main track that is controlled by an RTC is called Occupancy Control System, or OCS for short. And upon entry to OCS territory, you'll see a sign like this in the photograph. In terms of comparison to the United States, it's very similar to the track authority method of operation we use in CN on U.S. lines, or what track warrant system used on other railroads. It's a very flexible system. It doesn't require specific blocks. You can use whatever length of track you need in order to execute whatever movement you want. You're not giving out like a direct traffic control system where you have specified blocks. OCS is governed by rules 301 to 315, and we have a nice pad that everyone is issued, and you can pull, if you're a CN employee, you can actually pull it off the Operating Practices website and print as many as you want. This is the formal operating document that gets filled in to occupy the main track, do work, or move somewhere. We call it a clearance, and the authority to use that clearance is in effect until what we call fulfilled, which means you get to your final terminal and have exited the main line. It's canceled somewhere en route. You clear up onto a track that's not the main track, or is superseded by some new clearance to move elsewhere. It's our procedure that we can use to operate main track speeds without signal protection. And before anyone can go out there, obviously they need to copy a clearance and have authority to occupy. This is what this screenshot here is what the rail traffic controller would see when they issue authorities. And the CN application of it. And as I said before, the RTC is free to use whatever limits he needs between the beginning and the end of that segment of track to move a piece of equipment or a train. And also the engineering folks who show up in the blue bands down below with a name to show what limits they have for their authority to work on the track. In terms of the OCS system, in order to identify where you can go from and to, the limits are strictly defined by identifiable features. Besides the station name signs, we'll get to that in a moment, one of the key ones is we can use mileposts. Obviously, they better be pretty prominent and easy to see by the train crew. They can't be, some mile marker that's hanging off a tree or something like that. Station sign is also very common. It has to be very prominent. Most of them are posted right next to the track, like in that photo there. We also use marked turnouts, ends of sidings, junction switches, etc., to designate limits of authority as well. So just a quick breeze through here of what the OCS clearance pad has on it. It has an address section, obviously, to give direction to who's allowed to go out on the track. There's a box for instructions to wait at a point, if necessary, before executing the instruction to proceed. There's a box in here that specifically designates what direction you may operate in, and that authority gives you direction to move from and to in a single direction only, with a couple of little minor exceptions, but this is only allows for movement in one direction. There's also the provision for bidirectional authority by using a work authority, and you can move back and forth at will once you have that. Then there's information about other authorities that may be affect within your limits. We do allow you authorization through, say, working limits, but you have to have information who to contact to get through those working limits for obvious reasons. Information concerning turnouts that may have been left in the reverse position because of other movements. We do allow in Canada turnouts to be left in reverse position as long as authority has been granted by the rail traffic controller. And that is granted by the next box down below here. And then finally, once the authority has been copied and repeated correctly, it is completed with the boxes at the bottom. And then there's provision to cancel the authority if it's no longer needed anymore. Turnouts in OCS territory are generally always manually operated. There's a few instances out there where we have push button or radio control, such as this location in the photo on the Arnaud Railway, and they look a little bit more high-tech than just a regular switch stand. And much like written authority systems in the U.S., the efficiency of our OCS is totally dependent on forward thinking by a train crew or the RTC to get manual authorities in time to keep moving. The workload and responsiveness of the RTC, that's fairly obvious. And the effectiveness of radio tower communication. At this point in time, once a train gets out of a terminal, the only way they have to communicate with the RTC is via radio. They don't have a data radio system or anything to electronically distribute clearances yet. So just a quick example of an OCS operation is a subdivision that used to be part of the CN network in Ontario. This would be what you would see on a OCS subdivision page. OCS clearly marked as the method of control on the left there, and I'm just going to show you how this would look on track plan here using the segment of track between these two locations, Breslau and Kitchener, which used to be right down the street from where I went to university. So that's a track plan on this slide here. We have Breslau on the right side, Kitchener on the left, and a number of tracks and switches. The main track here is, as you can see, is what I've shown here in green. So that's where the OCS rules apply, is on that main track segment. From the timetable before, the eastward direction is heading toward, going to the right, towards Breslau. I didn't point it out before on the previous slide, but Kitchener has a designated passing siding, and it showed in the timetable 13,550 feet. And that's a place where you can direct trains to take or leave siding for meet purposes. The track at Breslau, although it looks like a siding, did not have a siding measurement shown in the timetable. And as such, it's just considered to be an other track, non-main track. And it isn't something that you can use in an authority necessarily to use for a meet or pass location, although there are ways of using it for other things. But that track does not need to be kept clear of equipment or anything, unlike the designated siding. And then in terms of what we would issue for OCS clearance limits, you could use the siding west switch Kitchener, and then the Kitchener station name sign, and the siding east switch Kitchener. All three of those locations are valid limits of authority. Breslau station sign could be used as a limit of authority because it's in the timetable, but its switches cannot be used as Kitchener would be. They're just considered just a plain switch. You would not use those locations in authority. And the little train showing the black arrow in the siding, the way it's been written there, 5:45 WK, which means work. 5444 is a train that would have some authority to work by OCS clearance. And that's basically how a OCS segment of track would look in plan view, and how you would what you could use to dispatch it. Now we'll move on to signal overlay. In the Canadian operating rules, we got three main methods for controlling movement using signals, and that's automatic block signals, which is rules 505 to 515, and CTC, of course, which is much more popular, which is rules 560 to 578, and then interlocking for more complicated or bridge type, movable bridge type situations with their own set of rules. In Canada, ABS and interlocking, much like in the United States, basically evolved over the same period, starting from around World War I or so. CTC first came to Canada in the early 1920s, but the real significant installations didn't show up until the World War II era. On the main track, under any of those signalized methods of control, the signal aspects and indications are provided by another very specific set of rules. And this is kind of a big difference between Canada and the US. We use only one set of signal rules, aspects and indications. And they're all there in that chart. It's based on the speed signaling system. So everything is, except for things such as the clear signal, which means proceed, and the stop signal, which means stop and restricting. The rest of them are, the definition all circulates around speed. It's a speed to another speed. And we use a combination of colors to convey that information. We also use, excuse me, in Canada, we also use a number of letter markers on the signal mast in order to upgrade certain indications. For example, limited speed signal indications can be developed by applying a L marker on the mast to a signal that displays medium speed indications. So a medium to clear indication could be upgraded to a limited to clear simply by the application of the letter L plate on the signal mast. Question? Yes, there are. It is maybe difficult to see, but there are flashing indications there. It's a little bit difficult to see on the overhead here, but they are there. Yeah.
Sean?
Dr. Martin.
Could we go back to that previous?
Yeah.
Can you, what would be an application of why you would want to use the limited plate to upgrade certain signals? Is it something that would apply to one train versus another train at that signal location?
Well,
in other words, why wouldn't you just have a limited to medium as opposed to a medium to medium with an upgrade?
Well, this again goes back to a little bit of economics. When the limited speed was first introduced, they hadn't quite come up with the concept yet of the flashing signal head. Yeah.
Gotcha. The turnout and put the plate on there rather than rewire the circuitry.
Yeah. So it's not something that, because I could envision a situation where you had two train types, say a passenger and a freight train, that might have
now
interpret that.
You do bring up an interesting point there, because there are locations in Canada where we do have, especially when we introduced the DV, which means diverging, which upgraded slow speed to diverging, 15 up to 25. There are some places where there's an illuminated DV sign, and when it's when one route is lined, it may be slow speed applies, the DV sign is not illuminated. But in a different application, a different route is lined that only goes through a diverging speed turnout, the DV will be illuminated. The L triangle plate only shows up, it never shows up in an illuminated on or off situation. It was just a economical way of getting that particular aspect and indication into the rule book quickly.
Presumably not used in new work either.
Not used in new work anymore, no. Yes, another question.
Is there significance of the shapes? Like the L is on the triangle, but the A is in a circle, and DVs are in rectangles?
Yeah, well, there's, it's just strictly that the shape is important. Sorry, for those online, the question is there significance to the shape of the letter plate? And that is, in this case, only the L plate in the triangular shape is to make it distinctive, so that even if you can't see, the L becomes obscured or whatever, you can still see it from a distance. It's that triangular shape. You know it's a 45 mile an hour.
So anytime we see a triangle, it will always be an L.
That's right.
That's
Yeah.
true in the United States as well,
Yeah.
when that is used also.
Yeah. And then in Canada, we also have a very interesting little device, Rule 440, down in the bottom right-hand corner, which is the direction indicator, which we use in certain applications approaching sidings where there is the siding is not under full CTC control, and that provides advance information to the train crew approaching that siding location that the route is lined into the siding, and rather than coming up to the next signal prepared to stop, especially if it's a restricting signal application going into that siding. Automatic block signals, like I said earlier, at CN we have basically eliminated the use of ABS. CP still has some significant segments of ABS on their territory. Western Canada between Edmonton and Red Deer, and then in Eastern Canada and Southern Ontario, west of Toronto, north of Toronto, and a double track operation going from Smiths Falls towards Montreal in the east. And there's really nothing new there. The application is basically essential to what has always been used in the United States. Rules 505 to 515 govern its usage. And it is used in conjunction with the OCS rules. The ABS, of course, it only provides information concerning broken rail protection and following and head-on train protection. OCS is your authority to actually occupy the main track and move somewhere. And in ABS territory, regardless of signal type, all signals are identified with number plates specifically for identification purposes in documentation, including the absolute signals at the end of a siding location that govern the movement to the next station, which is different than in the United States application. CTC in Canada, basically we followed the experiences of the United States roads and started getting into CTC from the 1920s onward. CP put the first real substantial installation into service out in Medicine Hat, Alberta, and it governed movements on a 6-mile, 1% hill that had helper operation and had a lot of back and forth movement. And which previously had been dispatched using a electric staff type system. And they need basically, just familiar story, they needed more capacity, and they needed to get something that was more robust to move more trains over this segment of track. And all it included was a select number of controlled signals at either station and 2 power turnouts. CN was the first railroad to commission a long-distance single-track CTC application between Moncton and Halifax in eastern Canada. And basically that was installed to help with the efforts during World War II because we had a severe problem with trying to get ships out of the harbors at Montreal and Quebec City. Germans or U-boats were actually coming into the St. Lawrence River and torpedoing ships. So Halifax was a much easily more defendable harbor area. And this segment of CN was the only place between Montreal and Halifax where there weren't parallel lines. And it was strictly a single track train order type operation. And overnight they went from a handful of trains a day to 40 or 50 movements a day, and they needed something installed fast. And this project was completed within 2 years. In Canada, based on the success of that application through the 1950s and in the 1960s, CTC was basically installed very rapidly on all the core main lines in Canada. And the two heavy iron ore railroads that opened up in the late 1950s in Quebec and Labrador in eastern Canada. Just to give you an idea of the just how widespread the network is, the highlighted routes on these two maps from western and eastern Canada basically show where CTC is in effect in Canada. It's never really expanded much beyond the core mainline network, just because the traffic density is just not there for the most part in Canada on most of our secondary routes to support the investment in CTC. Just quickly, this is what a rail traffic controller would see on a CN RTC2 track panel that we use to dispatch everything in Canada. Station names in yellow across the top of the track lines. Main track. Controlled signals are indicated by the various little triangles and are fairly obvious to spot. Anything that's shown in here as what looks like a switch is a switch that can be controlled by the RTC and would have a power or dual control switch machine. And then the trains basically show up as your red lines as track occupancies. Nothing really fantastic or much different than US displays. Track plan view of a single track CTC operation. This would be a segment on CP main line. It's basically identical to US installations today. Historically, there were a couple of little differences, but over the last 20 to 30 years, basically everything has started to look effectively identical, with a series of controlled locations marking the ends of siding locations, and then the application of intermediate signals in between. And the station names are not quite as important in CTC as they are in OCS. They don't really convey specific operating authority. That's what the controlled signals are used to designate, not the station names. Station names are used as identification for signal features that are out there in the field. And then industry track, of course, would be back under what we discussed earlier, under Rule 105 authority. And back to something that I talked about when we were discussing ABS. We have identified all of our signals in CTC with number plates, and that's to facilitate written authority procedures. This is a photograph of a location on the Quebec North Shore Labrador Railway with 3 controlled signals and 1 dual control switch. And the arrows there point to the 3 controlled signals. And you'll see that each one of them has a number plate on it. And when a written authority is required to pass a signal at stop or to give maintenance away authority between 2 locations, they use these number designations as that limit of authority instead of going through a big, long discussion and trying to describe what that location is. Dr. Barkin.
So I take it these are absolute signals.
Yes, they are.
So is there some other means by which a crew member knows or can distinguish between absolute and permissive signals? I mean, as you know, of course, in
Yes.
typical U.S., these would not have
Yes.
a number plate. So.
Yeah, the difference in Canada, first off, anything that is a single head signal is a permissive signal. We have no absolute signals with only one signal head, unless it has an A marker on it. So that's one thing.
Okay.
And then the second one is if we need a absolute signal or intermediate signal that needs two heads to display something, they are staggered, one on either side of the signal mass. So you get like a kind of a diagonal effect when you look at the.
So even if they're color lights, they'll be staggered.
Yes,
okay,
they will be.
Gotcha.
Yeah. And that's all demonstrated and shown in the signal aspect chart. Just like in OCS, every train crew has to carry around, and every engineering work group has to carry around a written authority pad. In CN, we call it the track warrant, which is interesting considering what track warrant means in the United States. It used to be called CTC authority form. This document is used by a rail traffic controller to give information to a train crew, for example, to pass a control signal that's displaying stop and cannot be cleared for some particular reason. That's governed very specifically by Rule 564. This document can also be used to allow engineering forces or train crews to work between defined signals and take switches off power and operate them in hand throw as they see fit to do whatever they need to do. And this document is also used for permission to enter the main track from a hand-operated switch. It's a little bit different in Canada. We don't necessarily need an entering signal or an electric lock on every hand-throw turnout in CTC territory because of this provision that we use written authority to enter main track at hand-operated switches. Moving along, go to the next big group of control. Would be interlocking. And in Canada, that's under Rule 601 to 620. And we have four main types in Canada that are specifically identified in the rule book. And instructions are specifically written out about how to deal with each one of these. There's what they call a manual interlocking, and that does not mean a place where there's gates or stop signs. This is in there more as a placeholder right now, and it's for a form of interlocking that we don't necessarily haven't thought about yet and may want to introduce. And it would only be governed by special instructions developed by the railroad and approved by Transport Canada. But the other three are typical to what you would see even in the United States. The locally controlled style of interlocking, which means there's a tower nearby. Remotely controlled, which would mean the rail traffic controller from a remote location operates it. And then automatic, which is usually nowadays restricted to just simple diamond crossing locations. Also governed under interlocking would be things like movable bridges. It doesn't necessarily mean that this is a diamond location or a major terminal. There's also a very specific rule. It's interesting that it falls under interlocking. But we have an interlocking rule for what we call non-interlocked crossings and movable bridges, which would be stop sign or gate or something like that. In Canada, we've seen quite an evolution in interlocking control, very rapidly have moved away from the classical definition of the interlocking with the control tower and diamonds like this photo from around 1923 at West Toronto. At that time, it was locally controlled. By the time this particular location was retired just last year, it had been completely remoted and totally under the control of the Canadian Pacific RTC from various places, Toronto, Montreal, and then eventually Calgary, before it was retired and replaced by a fly-under for a new GO Transit project. But again, evolution in Canada has been much more rapid to eliminate the locally controlled locations than it has been in the United States. We're down to only a handful in the entire country, and basically most of those are in Toronto. This is one of the last ones here. This is a sample of the track diagram for Scott Street Tower, which is on the east side of Union Station in Toronto. Anyone hazard a guess on just how many levers and controls? And Mr. Roma, you're not allowed to answer this one.
I was going to say a lot.
A lot? 120 from someone? They're very close, actually. Well, this particular location was opened with the complete rebuild of the Toronto Union Station area. Opened in 1931 with 78 signal levers, 84 switch levers, and 192 levers in total.
The length of this rule, probably.
Pretty much. However, even this location, and there's two others nearby in Toronto governing the Union Station Rail Corridor, are under plan right now to be eliminated by what we would now call a remotely controlled interlocking system as part of the GO Transit and Metrolinx expansion plans for the Union Station area. Yeah, the question was whether that project will rationalize or just transfer control. And in fact, if anything, there'll be even more track once they're finished there than there is now. But yeah, for the moment, the main thing is to transfer control to a more modern control system. Future control systems are provided for in Canada, specifically in the CROR. There's a segment in the rule book that provides for what we call a special control system. And there's three little rules in the rule book, 351 to 353, which basically says they'll be governed by special instructions once we figure out what that's going to be. It may seem kind of ridiculous, but actually this little group of three rules has been in effect in various rule books since the UCOR in order to implement various new methods of control as they are developed and come into practice. And in fact, our occupancy control system, which at one time was called manual block system, was implemented using these three little rules back in roughly 40 years ago. So we do have in print at least a way to incorporate and start work on whatever our next control system is going to be going forward, which right now does not look to be PTC. There's currently in Canada no specific mandate or requirement to implement PTC, unlike in the United States. We've taken a bit of a wait and see methodology to see what happens with the United States application. And although there's been some incidents where the subject has come up, so far nobody has come out and said, legislated any kind of rulings or mandates that say you must do this by X date. So in conclusion, just to wrap up a few things here, we in Canada, we've continued to make a single rulebook methodology work, despite the fact that CN and CP as we've moved on, CN has dropped certain methods of signal control like ABS, even though CP continues to use it. But even still, we've been able to handle that by CN using its tailor-made rule book and just not using those rules, as long as we're not going to apply that method of control. So we're able to make our single rule book work as we keep moving forward. In terms of hardware, what we use in our control systems is basically identical to that in the United States. My role in signal design, we specified products and equipment that was sourced from the U.S., basically. We have no signal manufacturers specific to Canada anymore in existence. And from what I've seen so far, the procedural differences for operating authorities and certain methods of control, think of the number plating on absolute signals, the need for written authority to pass stop signal indications, et cetera, are likely to remain in force. It's almost impossible to institute a change that reduces the amount of safety or rule enforcement that's in the CORR. You can always add to it and make things more restrictive, but to get rid of certain things is almost unheard of, and it becomes things have changed over time. Certain things have been incorporated and amended over time, but certain applications are unlikely to ever change. And if anything, maybe in the U.S. you will move to join some similarities that we possess up in Canada. And with yeah. Yeah, thanks, Mike. The point there, for those on the online, being it's very difficult to make changes even if you need to reduce your method of control. Say if your traffic reduces and you have CTC in effect, it's almost impossible to eliminate it in the United States. There have been select number of occasions where that has happened in Canada, where we've been able to economize and demonstrate through risk assessment that the method, a particular type of train control is no longer needed on the basis of the traffic just isn't there, or the operation has changed considerably. And one other thing, just before we conclude here, one thing that you may have noticed is we don't have and never have certain types of train control in Canada, such as automatic train stop or automatic train control, except for a very limited application in Southern Ontario with the New York Central / Penn Central / Conrail, operate a main line through Southern Ontario where they applied a automatic train stop system, but the Uniform Code of Operating Rules was actually the governing authority over that operation, and they just added on the necessary rules to cover ATS beyond what was in the UCOR to deal with that situation. In that case, that was an added safety enhancement. But the remaining CN and CP never saw the need, effectively because of much lower traffic volumes in Canada, to ever need those types of systems, and they were never applied. And that concludes my presentation, and I'd be happy to take questions and other comments. Yes?
I noticed in a much earlier slide a track length was given in English rather than metric. You do use metric units for length speeds, etc.?
No, Canadian railroading, just in case anyone didn't hear that, the question is, are we using the metric system in Canadian railroading? And the answer is no. We are still using the imperial system, except for there's a couple of what I would call minor operations where they are using the metric system. The provision is there to use it, but CN and CP are so intertwined with the U.S. networks that it's never made any financial or economic sense to make that switch.
Eric, question. Can you speak to like general track operating speeds? As you know, in the U.S., the FRA has guidelines based on limits with dark territory, CTC, less than 80, automatic train stop, you can go faster, et cetera.
Yeah.
Can you compare and contrast what you guys have in Canada as far as what Transport Canada enforces, if anything?
Track speed in Canada is based solely on class of track as defined by its maintenance level. It's got absolutely nothing to do with method of control, whether it has signals or not. We had what we would call basically highest class of track, qualified for 90-mile-an-hour passenger train operation at one point in time that was under OCS control with no signal overlay whatsoever. Our speeds, are just solely based on the standard of maintenance of that piece of track. So we had the interesting quandary, in eastern Canada there used to be segments of track in dark territory where they were operating passenger trains at 90 miles an hour, yet I can go to other places in the country that are under CTC that were only operating at 30. So it's all solely based on curvature and track design and class of maintenance.
More or less the ARIMA track standards?
Yeah, fairly close, yeah. Next question.
Great presentation. Two questions. You mentioned the dependence on voice communication for track warrants as opposed to, for example, data radios. Does that imply that you have universal radio coverage throughout the network? Is a crew always going to be in touch with a dispatcher by voice?
Yeah, over the years, once we, it came in stages, but over the years, once the OCS system was basically universally adopted in order to eliminate the train order control system, a big push was instigated to get radio coverage on every mile of track in Canada. Now, obviously, in some situations, because of terrain or weather conditions, there can be intermittent issues with radio coverage. I personally experienced that myself in situations on the track. But we'll say, in theory, every mile of track has radio coverage out there. And not just in OCS territory, in all the CTC territory as well. And as a result, because of that, all the other methods of communication, such as like trackside phones at controlled locations, all that, were all eliminated, ripped out as cost-saving measures once the radio system was proven to be effectively reliable network-wide.
Thank you. And then the second question was, you mentioned the lack of a PTC mandate. For a company like CN, which is essentially a binational railroad, what percentage of your power will you have to equip with PTC equipment anyway to comply with the American mandate, just to be able to do run-through across your network?
Yeah, effectively, the entire road fleet will have to be equipped, is basically the short answer to that. So once you take out the yard power, basically you're looking at 60 to 70% of the fleet. Because we don't have necessarily an assigned strategy for motive power. Any locomotive can go anywhere. Dr. Barger. Yes.
Hi. I'm curious as far as language issue, especially in Quebec. It looked like everything, are all the papers always in English, or can they be either language, depending on location? How does that work? And voice radio as well.
Excellent point. All documentation is in both official languages. So There is a French version of the CROR. There's a French version of everything, all the Transport Canada regulations and rules, whether it's for operations or mechanical or engineering. All the forms, like I've shown you in this presentation, are all available in French as well. In fact, once you go into Quebec, it's very rare to hear anything being done in English. That's just the nature of the culture there. We have a rail traffic control center, CN, in Montreal that handles everything from Brockville, Ontario, east to Halifax, Nova Scotia, and basically from Montreal east to almost Moncton, and all of northern Quebec is pretty much dispatched entirely in French. And so, yeah, we have the provisions, we have all the software, the computer software to run the signal control system is also in French for that office. And, yeah, all the paperwork, all the authorities, all the discussion is usually conducted all in French. Yep. Dr. Bargan.
So that raises for me a follow-up question, which is that Canada is a bilingual country,
yep,
irrespective of whether you're in Quebec or British Columbia. Do crews have the discretion to communicate in French in British Columbia? I mean, is that, or are there geographic limits to where you can use one language or the other, or can you go either way?
Well, there's no, yeah, I mean, there's no official thing saying, you know, east of here you can only speak French, and west of here you can only speak English. However, in practical, realistic terms, if you start speaking in French on a British Columbia radio tower, you're going to get a lot of quizzical looks on your face.
Well, my point precisely, but I guess...
Stop train is a safe train.
That's one way to look at it.
But so at the fringes, there must be some of this going on.
Well, absolutely, and that's what happens as you move east from Toronto. Basically, it starts happening around Belleville on the Toronto-Montreal main line, because east of there, you start getting Montreal crews that come west, and most of them are primarily French-speaking. They know English as well, because they know once they have to deal with the Rail Traffic Control Center in Toronto, it's probably likely they're going to have to speak in English. When you get through, there's sort of a gray area there, through to Montreal where you got crews working in both languages. So the Montreal RTC office, basically, most of the office staff is bilingual, although most of them are primarily Francophone background. But so if you're working, in a Montreal terminal area, you got to be able to switch back and forth pretty quick. But once you go east of Montreal, it's kind of the opposite. Until you get to around the New Brunswick border, then eventually it starts to slowly go back to English again.
Any other questions? Well, if not, let me repeat Chris's comment. It was an excellent seminar. Thank you very much.